Alright, so what we're going to be covering in this video is the properties of logs, how to convert them, how to simplify them, and so forth, or expand them. So in order to be successful, we need to review some things. So when I have a negative exponent, that means I do 1 over 2 to the third. Anything to the 0 exponent is 1. Square roots can be written as exponents. If you remember, we did this back in the, I believe it was second 9 weeks, maybe the beginning of the third, is you do turn the fraction, square root is 2. This one has an exponent of 1 already, so it'll be 1/2. This one will be 11. The exponent on the 11 currently is 1, so it'll be 1/3. This type of problem, two things are going to happen. One is going to become negative because it's a fraction. So that means it was a negative exponent. Square root, that's 2. The current exponent's 1, so 1/2. Okay, so the outside of the square root symbol or the radical becomes the bottom part of the fraction. So this becomes 3. If you had something like this, then it's equivalent to x to the 3/4. The 3 is your exponent. This becomes your fraction part. Okay. All right. So going into the actual notes for today, what we're going to be doing is converting exponentials to logs. So what I told you last class was that the base is what's going to be the same. So this is going to be log base 2 because that's my base. Now the other two parts switch because they're inverses. So it'll be 8 equals 3. So log base 2 of 8 is equivalent to 3. All right, for this problem, the base here is 3. Then I'm going to switch the exponent and what it's equal to. So it'll be 1/9 equals -2. All right. This problem, I need to do a little work before I get to do this. I need to change this to an exponent because if you don't have exponents, then something's not right. So this is equivalent to 81 to the 1/2 power. So now my base is 81. That's what's underneath the exponent. And then I switch the 1/2 and 9. So 9 equals 1/2. Okay. Same thing here. I've got to convert it. So it'll be 27 to the 1/3 power. So then my base is 27. And I switch the 3 and the 1/3. Whoops, I put a 2. Sorry. All right. Now going the other direction. I need the base. The base is 2. Then I'm going to switch. So the exponent's now going to be 4 equals 16. Now when you do it this way, it should make sense. 2 to the 4th power is 16. All right, my base is 3. And then I'm going to switch. It'll be -1/2 is equal to 1 over square root of 3. And yeah, 1/2 is square root. So, and negative means you flip. All right, so that's how you convert. You start with a base and you switch the other two components. Okay, going from exponentials to log, you need to put a log. If you're going from log to exponential, then you need to put an exponent. Okay. All right, so using that, we're going to evaluate these. I want to figure out what is this equal. So I'm going to convert it to exponentials because I know how to find exponents of stuff. So 7 to what power will equal 49? Because 7 is my base, and I switched the 49 and x. Well, hopefully you know 7 squared, so x must be 2. All right, same thing here. It'll be 3 to what power equals 27? Well, 3 to the 3rd power. Here, 6 to what power, because that's what I'm finding, equals 1/6. Well, how do I turn 6 into 1/6? X must be a negative exponent. All right, going from here, I want to know what this equals. So 3 is my base. Then I switch. X equals 1/9. So let's see. How do I turn 3 into 1/9? Well, I need to square it, but it's also going to have to be negative because it's a fraction. Okay. Then going here. 6 to what power will equal square root of 6? Well, square root is 1/2. So x must be 1/2. All right, next problem. I want to figure out what this equals. So 3 to what power will equal 1 over square root of 3? Well, square root is 1/2, but it's a fraction, so that must be this exponent is negative. All right, going to this problem. 81 to what power will equal 9? Well, to get 81 to 9, I must take the square root. So x must be a half. All right, 12 to what power will equal 1? So this one, what power can I plug into 12 so it equals 1? That's that rule I told y'all earlier, 0. Anything to the 0 power will be 1. Okay? All right, now, so remember some of the common ones. So this one, the base here is 10. So this will be 10 to what power, because that's what I'm trying to find. What does this equal? Will equal 10 squared. Well, that's pretty easy. X must be 2. All right, again, the base here will be 10. So 10 to what power, because I got to switch it, will equal square root of 10 to the 5th power. Now, let me convert this to exponents. That's going to be equivalent to 10 to the 5 half power. So then x must be 5 halves. All right, same thing here. ln means it's a common base e. So if I want to convert it, e is my base. Sorry, I was not supposed to put e there. I'm supposed to put x. I want to find out what this equals. So e to what power will equal e squared? Well, obviously, x must be 2. All right, same thing here. Base is e. I want to know what it equals. So e to what power equals 1 over e? Because remember, all I'm doing is switching these two places. Well, let's see. This is a fraction. So that must be x must be -1. All right, same thing here. I want to know what this equals. So e to what power will equal square root of e? Well, square root of e means that this is e to the 1/2. So x must be 1/2. All right, so converting between the two, you write your base, and then you switch the other two components. All right, so now we're going to be doing some other rules. Because logs and exponents are inverses, that means they undo each other. So if I take log a of a to the exponent, these things cancel out, just like these things cancel out. So if I have log 5 of 5, that cancels each other out. So then x must be equal to 2. All right, now this, remember, ln is base e. So then these e's cancel out, and 3 must be x. Here, 7 and a 7 here cancel out. 5 must be x. Again, this is, remember, e. So then these e's cancel out, and I just got 8 equals x. These cancel out. 11 equals x. Then here, this one's a little tricky, because log base 10 is 10, but I don't see 10 in here. But I could rewrite this as log 10 of 10 to some power. Now let's see, I know 10 squared is 100, so let me see, 10 to the 3rd is 1,000. So there we go, 10 to the 3rd. So then these cancel, and x must be 3. Okay, so when you have an exponential and a base, two bases that are the same, they cancel each other out. Okay. All right, so now we're going to talk about the properties of logs. Now, these properties of logs come from the exponent rules that we learned back in first 9 weeks. You also learned in Algebra 1. When you think about exponents, when you multiply x times x, that's x squared, because 1 plus 1 is 2. X squared times x to the 3rd is x to the 5th, because 2 plus 3 is 5. So same property holds here. When I see addition, I get to multiply the insides. When you divide exponents, you subtract. So when I see subtraction, I get to divide the insides because they're inverses, they're opposites. Then power rule of exponents was a power to a power, you multiply. So example, that was like x squared to the 3rd. 2 times 3 is x to the 6th. So here, when I see a power, I get to take it to the front. So if I have something in the front, I get to make it a power, vice versa. So these rules can go back or forth. Okay, depending on what you're going to do. So, putting it together, in the first examples, we're going to expand. So we want to take these single logs, and we want to make them bigger. So we're going from this right side, going to the left. Okay, so I need to start with what makes the most sense. So first thing that makes sense is I want to get rid of this fraction. I want to get rid of division, so I can touch the rest of the stuff. So to get rid of this division, I need to do subtraction. So it'll be log a of the top piece first, 2 square root of p3 minus, because that's the rule, log A, keep the same base, and that totally doesn't look like an A, sorry, and that still doesn't look like an A, right, of now the bottom piece, so QR4. Alright, now from here, I'm going to focus on just one at a time. So I'm going to focus on this first one. I want to keep trying to separate this. So this 2 is connected with the square root P3 by multiplication. So multiplication, to separate, I need to do addition. So this would be log A of 2 plus log A of the square root P3. Now, I'm going to go ahead and change this to P3 over 2 because I don't like dealing with that square root symbol. Okay. Alright, now I'm not finished with this left side. I'm going to come to the right side in a minute, but I'm not finished. Now 2, there is nothing else I can do with that 2. So that's log A2. But I can do one more rule with this P to the 3/2. This 3/2 is an exponent. So when I see an exponent, all I have to do is move it to the front of the log. So that'll be plus, this exponent now will be 3/2 in front, log A of P. Now I'm finished with the left side. Alright, the right side, bringing down that minus sign, keep bringing it down. I see QR4. I need to first separate that Q and R. So it's multiplication, so I separate multiplication with addition. So that'll be log A of Q plus log A of R4. Now, that R4, I can do something with that. That's an exponent, so I get to bring it in front. So that'll be log A of Q plus 4 log A of R. Now, I am not done, technically. This first part, we're done with that. Log A2 plus 3/2 log AP. I'm not done because from the beginning, we were subtracting all of this. So I have my subtraction here. Sorry, plus 4 log AR. I need to use parentheses, okay? Because I need to know that, hey, I first need to put these back together, then do subtraction. So when you do this, make sure you use parentheses, okay? All right, I'm going to do a part 2 for the next problem.